Good afternoon. My name is Glenn Larson. I'm the Senior Catia Applications Engineer with Vice Corporation, and we're here today to talk about how we're going to use Catia to help with FEA analysis. And we're going to do so specifically by starting out with talking about reverse engineering. A lot of times in reverse engineering, and we're going to mostly go into the point cloud data, but we talk about the different types of data that we can get to engineer from. Sometimes we get surfacing, sometimes we get prints, sometimes we get a picture, or even a 3D picture is shown here, can be used. We're going to start with talking about the digital shape editor and the point cloud. Point clouds can come in many formats. The format I'm using here is the NSC format, and it's one of the more common ones used, and it can be done with LiDAR or just regular laser scanning. With you can have pictures, can add in all kinds of shading. You have a lot of ability, but in the end, you really only need a point cloud, and you can see from the picture how accurate it is. You can see the heat from where they welded this section together, and so it's accurate. So we're going to go to the live portion of the demo. So here we are at the live portion of the demo, creating a model from a point cloud. So we're going to start out by opening up, and we use 3 apps here to do it. Basically, digital shape preparation, digital shape sculpting if needed, and digital shape to surface. So let's go ahead and open up the digital preparation, shape preparation. So we're going to make a new geometrical set to store the data in. And I'm going to go out and find the data after I name it, call it the point cloud. So let's add the points. So here we can add points in several different ways. We have, first of all, a large digital file, which would be stored on a server and you would just tap into it, or just the digital file, which is what we're going to use here today. It's a little bit smaller, might be one object, right? Not a whole faculty. And so we're going to bring in my ASC random data. And you can see here, you just have to check it and say it's okay. So now we get to where we're going to import the data, and we have the different data types. So you can see all the different data types that we have here, and there's different types of ASC files. Some have shading, some do not. Okay, so we're going to pick up the ASC3, and it's going to be 1:1. This is where you could scale it. If it was a really big file and you wanted to make it smaller for some reason, you could. So there's all the points. And what we're going to do is just grab all the data and activate it so it's all active. We make sure we can touch it and use it and delete it and edit. So here I'm going to take some of the random points out that I know that are going to, because it goes on, when you start filtering, it's going to go statistically. So you want to filter as clean as you can. So we'll trim out that data, go to a new view. Let's go ahead and filter the data. I'm going to use a 1/4 inch because this is going to surface on tangency. So we don't want it to look like a piece of aluminum foil. So we got some nice clean points. So now we basically, after having the points, we just basically click the points and click the mesh, and it just created the mesh for us. That went a little fast. So now we're going to make a new geometrical set, and we're going to call it the surface. This is where we're going to create the surface. I like to keep things in different sets so I know how to find them. I'm going to go ahead and switch over to digital shape recreation. Okay, so we just click on the mesh and basically click on the surface. It's that simple. Now you can see that there were some obviously choices there. So we're going to create another set, another geometrical set to actually put the surfacing into, or to the trim surface where we're going to work. I'm adding in a plane. I'm going to go ahead and trim it because when they want to go ahead and do an FAA analysis on this, it has to be to the right print size. So let's eliminate the random data. Let's go ahead and trim the bottom. So now it's the size. Now we're going to go ahead and we're going to put a sideways plane in because let's say I'm reading the print and I'm going to draw in some features here. I'll put my generative shape design. We'll sketch right on there. I'm going to use a box. Happy to always constraining my geometry. Now we're going to extrude that through. I'm going to go 2 inches in either direction to ensure that you pass all the way through the curve, through the arc. This way is trimming it, makes it clean. So now we'll make a split, and we'll split 2 parts. Trim that there. Now we're going to go ahead and merge these splits. So now it's one piece. Now, if we want to, we can use contextual menus to just say, oh, we want to put a radius in here. Because the contextual menus will allow you to just pick on a feature and it'll tell you what's available. Really fast modeling. I'm going to go ahead and radius all these edges here. You can put the dimension in here, or you can just click on the part and actually change that dimension right there. You can actually watch the model move. So that's basic surface construction. So the next thing that we're going to talk about is basically how to take a picture or a two-dimensional print and bring it into the Catia to go ahead and reverse engineer right from it. So here we have a picture of a Corvette, and I'm going to show you a video on how this is done. But we bring this photograph into a CAT file, and we can scale it up. I happen to know that a Corvette is 98-inch wheelbase, so I can put that right in there. And then we get to the question a lot of people might have on their mind, what is this? And if you haven't seen this before, this is the way that aircraft was drawn and also ships for many years. Basically, the way that you get a shape is to take the different planes and section them and see what that cross-section looks like. So sometimes to create surfacing, this is the way that it's done. If you can see a Mylar, or what they call the Mylar, is they would draw this out and print it on plastic to make it more stable over the length of Mylar plastic. And then we go ahead and we bring in the picture of it into Catia, again, like I did with the Corvette. And you can put these on station. So usually an aircraft print would go on station 0, or you'd put it in front of station 0 of it. Okay, here we are at the live demo of in aircraft manufacturing is how to create a loft contour drawing. And again, this could work for anything you wanted to sketch. So the very first thing that we're going to do is let's bring a photograph in. And I've opened a program called Sketch Tracer, and it brings in basically a product file. And if you can see, it gives you planes to go ahead and start putting your drawings on. And you can put the axis where you want, so we'll get into that a little bit. But I'm just going to put this on the front view. It's going to be my very front view. It's real simple when you're going in one direction. I'm using a TIFF file. but you could use any kind of a picture file that will accept a JPEG or whatever, what have you. TIFF files are usually high definition and therefore a little more stable. But you're going to go ahead and scale this, and aircraft prints are put on inches in split lines and water lines. So we're going to go ahead and we're going to get this as accurate as we can right in the center of that spot. And since we're going in one direction, we just really have to make sure it's center on that line. And normally when you scale this in one direction, it will scale in both, but it's best practices to scale both directions, both in X and Y. Again, you get that line as clean as you can on top of there. Now I'm going to come down butt line 50 to butt line 80 is 30 inches, so we're just going to type in 30 inches. Now we can insert the planes and lay the sketches on the stations. So I'm going to go ahead and put in planes, and what you can't see on that print, because you'd have to really go and zoom in close, is each one of those lines is on a station number, so many inches back. Station 10 would be 10 inches back, station 100 was 100 inches back, and so forth and so on. So each one of these lines will get created on its own plane. I'm going to show you very quickly here. We're going to draw one line, and we're going to create a sketch. And now I'm going to sketch an arc on this line. And it's not going to be just an arc. We're going to use spline for a whole design, because sometimes the arcs will arc in one direction and then arc in another direction. Lock that down. Now we've got a nice clean line. And if you could just say you just did all those lines, that's how you create that surface. It's really that simple. Really that simple. There's really important to make sure everything's scaled properly and read properly, but outside of that, Catia makes quick work of this. So there you have reverse engineering. Thank you for your time.